So in this video we're going to define the minors and cofactors of a square matrix A. So let A be a square matrix. The minor of element Aij, so that means, remember, little a represents any arbitrary element within a matrix. So like this element right here is the element A row 2 column 2. So it's row then column in the numbering. So the minor of an element Aij, denoted by big M sub ij, is the determinant. So big M sub ij is the determinant of the matrix that you get after you delete the ith row and jth column of A. And we'll show an example of this here in just a second. And the cofactor of Aij, which we denote with a big C sub ij, is just going to be the minor multiplied by -1 to the I plus jth power. So essentially what this means then is that Cij, if I plus j is even, is going to equal the M sub ij, and if I plus j is odd, then C sub ij will be the opposite of M sub ij. So C sub ij and M sub ij differ by only a power. So let's see how this plays out on a matrix. So I should have matrix notation on this. Let A be this fabulous matrix right here. Determine the minors and cofactors for elements A11 and A32. So A11, what you would do is take row 1, column 1, because the minor you get by deleting the ith row and the jth column. So we would take and delete the ith row and the jth column of A, and we would take what we have left and we would calculate the determinant of that matrix that's left. So what's left is -1, 2, -2, 1. And this would be the minor associated with row 1, column 1. And then the cofactor of 1, 1 would simply be take -1 and raise it to the I plus jth power. Raise it to the I plus jth power. So in this case we would go -1 to the 1 plus 1 power times the determinant of -1 to -2, 1. And of course -1 squared is just going to be +1, so we would just get the determinant of -1, -2, 2, 1. And each of these we could calculate easily enough. This would be -1 times 1 is -1, minus 2 times -2 is -1 plus 3 is 2. And so in this case the cofactor is going to be the same. If we calculate instead A sub 32, so we go to the element in row 3, column 2, row 3, column 2, we delete row 3 and column 2, and so the minor M sub 3, 2, the minor associated with row 3, column 2 is going to be the determinant of the matrix that we get when we take what's left after we cross out that row and column. So we get 1, 4 and 3, 2. And we could actually calculate this. So the determinant of a 2 by 2 matrix is the product of the first diagonal term. So 1 times 2 is 2. Minus 4 times 3 is 12. And 2 minus 12 is -10. And so the cofactor associated with row 3, column 2 is just going to be -1 to the 3 plus 2 times that -10. So we times it by the minor of the matrix. Of that factor in the matrix. So 3 plus 2 is 5, so -1 to the 5th power is going to be -1 times -10, and we just get a 10 out of this. So that's how you calculate them. These are going to be important to us because the formal definition of the determinant of an arbitrary square matrix is going to rely on cofactors in its definition. So we're going to take a look at that in the next video. and then after that we'll do some examples of calculating determinants.